If you want to know how to rig and move Hitfilm's camera, then you're in luck. Because that's what we're going to talk about today. In our last episode, we looked at ways of matching the Hitfilm camera's virtual lens to a real-world camera lens. Today, we're going to look at several different ways of moving the camera around the Hitfilm 3D space. I'm Mike Miller from Tri-M Visual. Let's get started. All throughout the last episode, you've seen quietly sitting here in the lower left-hand corner of the viewer this text object, scale, 1 inch equals 2 pixels. Hitfilm's universe is not set up to any kind of real-world scale. Everything is based on a pixel. When doing a pure animation like this, the scale is arbitrary and can be determined by you as the artist. Figuring out the scale when dealing with photographs or actual video can be eyeballed, and we'll discuss that a little bit later. Here we are in Hitfilm Pro 2017. We're looking at a piece of footage I shot for something that will come up later in this tutorial series. I shot this footage on a full-frame DSLR using a 24mm lens. I've already got a 3D camera set up in the scene, set to a 24mm zoom, which for this 1920 by 1080 footage is a zoom of 1280. I've also got a 3D plane in the scene with a grid effect on it. This plane has been set to 3D, and I'm going to quickly align this plane to the ground. I'm going to go ahead and change my video layer to a 3D layer for now. When I change the layer to 3D, it appears to recede in space. This is because of the zoom settings of this lens. What I'm going to do is move this layer forward in space just until it fills the frame again. Since this footage was shot with a 24mm lens and I have a 24mm virtual camera, moving this video forward in space to where it fills the frame effectively gives me a distance that I can use to set scale. Note that I could do all the following steps after scaling the video up where it was rather than moving it forward in D space. This would give me a different scale value, but both would be valid. I can't see my floor grid anymore, so I'm going to quickly create a grade layer and move my grid above it. 3D renders in Hitfilm are done in batches, and each 3D world batch is separated when it hits a 2D layer. By putting the grade layer in between my movie layer and my plane layer, I can now see my 3D plane layer completely above my video layer, even though they are in the same 3D space. I'm going to go ahead and import a 3D model quickly. And by coming over to the Advanced tab and making certain that Auto Normalize is checked, I know that this cylinder is going to automatically brought in at a height of 500 pixels. So when I bring the plane cylinder into the layer, I know that this is a 500 pixel high object. I'm going to move the anchor point on the cylinder and I'm going to align it with the center of the floor plane that I've created. I'm going to move the sphere forward using the grid as a kind of a reference line to try and line the cylinder up with myself. I'm going to call myself 6 feet tall. I'm actually 5'11 and a half. I'm going to unlink this cylinder from the ground plane. Ooh, I have to reset its orientation to get it in the right direction. And I'm going to go ahead and shrink this cylinder till it's the same height as me. That's close enough for an estimate. So I'm 6 feet tall. I brought in a cylinder that was 500 pixels high. That cylinder has been set to a scale of 85%. So if I take 500 pixels Multiply that by 0.85, then I get 425 pixels tall. 6 feet is 72 inches. So if I take 425 pixels and divide that by 72, then I see that the scale of the scene is 5.9027 pixels per inch. I would just go ahead and round that up to 6 pixels per inch. That gives me an approximate scale for the scene if I were trying to match objects in 3D space. Although, honestly, in most cases, just the eyeballing stage of putting the cylinder next to me on the ground and scaling it to the proper height would be close enough. So when we return to our original composite shot, we see that the scale of this scene has been set at 1 inch, being 2 pixels. Each of these female silhouettes has been scaled to be 5.5 virtual feet high, or 65 pixels. The camera has been set 10 feet in front of the 000 point for the universe. At a scale of 1 inch every 2 pixels, that's 240 pixels. The 3D building scale was kind of eyeballed by... The scale of the buildings was kind of eyeballed by moving one of the female figures into the doorway and scaling it so that the top of a female figure's head was hitting the bottom of this rectangle. So here we are in Hitfilm Express 2017. We're looking at a duplicate of our composite shot that we were using last week, and here on Layer 1, we have a new camera that has been created and left to its defaults. The first thing we want to look at is how to just move the camera on its own, and there are multiple ways to do that. The first way to move a camera in Hitfilm is to use the built-in camera controls, which are located in the upper right corner of the viewer window. This top arrow is a dolly control, and by clicking and holding with the left mouse button and dragging up and down, you can move the camera forward and backward in Z-space. Below that is the pan control, and by clicking and holding the left mouse button and dragging, you can move the camera vertically or horizontally. Below that is the zoom control. This changes the field of view of the camera, and by clicking and holding the left mouse button and dragging, you can decrease or increase the zoom of the camera. Below that is the rotate control. By clicking and holding the left mouse button and dragging, you rotate the camera around itself as if the camera were on a tripod head. One other camera movement control is located to the left side of the viewer panel. This is the orbit around selected layers control. Unlike the other camera controls, this is a toggle, and by clicking on it once to select it, and then clicking and dragging, in the viewer window, the camera will orbit around a selected layer or a selected point. At the moment, the selected layer is the latitude-longitude grid used in the last episode for determining field of view. It's currently off, but its position is set to the center of the universe, so the camera is rotating around the center of the universe. Instead, I will move up and select the female 3D's flipped layer. In the viewer, you can see this point determining the center of our flipped 3D females. Now, by clicking and dragging in the layer, the camera is orbiting around that selected point. By selecting the buildings layer instead, we now rotate around the center of that 3D unrolled layer. I just paused screen recording for a moment and created this new 3D point off in the distance. And by reselecting our orbit control, we are now rotating around that distant point. Let's open up the transform properties for the new camera layer and turn on keyframing for position, orientation, and all 3 rotation axes. We'll move the playhead forward a few seconds and use the camera controls to change the position and orientation of the camera. Using the pan and dolly controls moves the camera in 3D space, updating the position properties as we'd expect. And by using the rotation controls, the X, Y, and Z rotation properties can be changed by dragging with the rotate icon. However, this rotate control does not affect the camera's orientation. Let's select the new point layer, move the playhead forward a few more seconds, make certain that the orbit tool is selected, and move our camera this way. We'll go ahead and reselect our new camera layer, and now we'll open up its transform properties on the timeline. We can see that using the orbit control to rotate the camera around the selected point has created a new keyframe for position and rotation properties of the camera. Orientation is also left unaffected by the orbit tool. We'll move the playhead forward another few seconds and adjust the position and rotation of the camera by directly changing its position and rotation controls. So a Hitfilm camera can be moved by using the camera controls, the orbit control, or by directly changing the values in the transform properties for the layer. There's one more way to directly move Hitfilm's camera, and that is to come up to the active camera toggle at the upper left corner of the viewer and change this from active camera to perspective. The perspective camera in Hitfilm is a special kind of camera that does not show up inside the layer stack at all. The perspective camera is considered to be outside the scene and cannot be rendered to an export. The perspective camera is there to give you a neutral observer camera for looking at your 3D space. The perspective camera itself responds to the same camera controls as the regular camera. You can also move the perspective camera forward and backward in space by using the center mouse button, and the perspective camera also responds to the orbit tool. In this case, the perspective camera is orbiting around our scene camera because our scene camera is the currently selected layer. And if I move the playhead forward another few frames, activate the selection tool, and grab the control widget for this camera, then I can animate the camera by moving it directly in 3D space. This is a good time to look at this local control near the top right of the viewer panel. This drop-down menu affects how control widgets are displayed and act in Hitfilm's 3D space. With this control set to local, the control widget for any selected 3D object in Hitfilm's 3D space will be oriented in the way that the object itself is oriented. So the X-axis is oriented to the camera's left and right. The Y-axis is rotated to the camera's up and down. And the Z-axis is oriented to the camera's forward and backward. If I select the female's 3D flipped layer, we can see how its orientation is aligned more or less to that of the world. The X-axis is oriented to that of the world, the Y-axis is oriented to that of the world, as well as the Z-axis. However, this female's 3D flipped composite shot has had its scale adjusted so that its X scale is -100%. This has had the effect of flipping the control widget. And if I toggle this back to 100%, you see how the control widget has reoriented itself to the new dimensions of the layer. Here's a quick power tip. Any position or scale value can be inverted by holding down the control key and left-clicking on it. So as you see here, by holding down the control key and clicking on this X-axis, I can quickly toggle my X scale between plus and -100%. This works for position as well. I don't remember if it works for rotation, so let's test that quickly. Nope, that doesn't work for rotation, just for scale and position. Let's select this camera again and return to this drop-down menu. Opening that, we can see we have two more options, World and View. By selecting World, the control widget is now aligned to Hitfilm's absolute 3D space. No matter where I move this camera, the handles on the control widget are moving in absolute coordinates oriented to the center of Hitfilm's universe. Let's take a look at that third option, View. By selecting View, an object's control widget is oriented to the current active camera on the timeline. The View toggle does not work with the perspective camera because the perspective camera itself is considered to be outside the timeline. Because I have the camera selected, and this is the only camera within the scene, for this camera, setting the option to View is the same as setting it to Local. So I'm going to grab this female's 3D flipped layer again and toggle these options one more time. By setting the toggle to Local, the control widget is now oriented to the actual orientation of the layer itself. Moving and rotating the layer changes the orientation of its control widget. By changing this to World, the control widget is now aligned to Hitfilm's actual 3D space. No matter how I move or rotate the layer, the control widget stays oriented to the 3D universe. By changing this to View, the control widget is now oriented towards the active camera in the layer stack, which is this one. No matter how I move the layer now or rotate it, the control widget stays oriented to this camera. I'm going to pause screen recording and undo all those movements I just did. Okay, one last thing to note about the perspective camera in Hitfilm. The perspective camera can only see 3D elements in Hitfilm's 3D space. The perspective camera cannot see or render any 2D Hitfilm layers that may be in your composite. In this composite, we have two 2D layers. The first is this text layer, which is in this lower left-hand corner, saying scale 1 inch equals 2 pixels. The second is a grade layer that I've added that has a lightning effect stretching between new point and the center of the ground plane. The perspective camera is not seeing either of these two layers. When I change the camera back to active camera, our 2D text has returned and our 2D grade layer is now rendering in the frame. We'll be needing an observation camera later in this tutorial, but we won't be using the perspective camera to do it. While you can move Hitfilm's camera around using the camera controls, or the transform controls, or directly moving the camera's widget, usually moving Hitfilm's camera directly is not the smartest way to get smooth or realistic camera movements. But before we look at some of the ways to move the camera, we need to talk about how to rotate the camera first. I've gone ahead and reset my camera in the perspective view. I've added into the background a 3D unrolled composite shot of two wedges, here labeled Flying Arrow. Flying Arrow is just flying from left to right in the background above our scene. I'm going to return to the active camera view. In How to Animate Everything, Essential Hitfilm Episode 11, we discussed Euler rotation. Euler is the mathematician who first formalized the concept that an object's orientation in 3D space can be found by comparing the rotation values of three axes we call x, y, and z. We can see that in our widget. The red arrow is the x-axis, the green arrow is the y-axis, and the blue arrow is the z-axis. In Hitfilm, Euler rotation happens in a fixed order, no matter if it's a camera, a light, a 3D model, or a 3D plane. In Hitfilm, rotation operations are always performed in the order of x, y, z. The x-axis always transforms first, then the y-axis, then the z-axis. And this becomes very important when dealing with cameras. To demonstrate why this XYZ rotation order is a problem, let's shift out of perspective view and to our active camera view and try to animate our camera to follow the flying arrowhead. And before I take the next step, I want to change the camera's zoom to something much wider, from 3733.3 to 800. I'm going to go ahead and move the playhead to about 5 seconds in. My arrowhead is animated to move from left to right across the entire 10 seconds of the composite shot, so at 5 seconds, it should be right over our heads off the top of the screen. I'll open up the transform controls and set the X rotation to -60. And there it is, because I set up the animation to do that. I'm also going to go ahead and activate keyframing on X, Y, and Z, and then I'll move the playhead back to the first frame. I'm going to adjust the Y rotation to kind of look for my arrowhead. There it is. And then move to the last frame and also adjust my Y rotation to look for our arrowhead. There it is. So when I scrub the animation, the camera is panning to follow the arrowhead as it flies overhead, but we can see a problem with the ground plane. The ground plane is aligned at a strange angle at both ends. We're going to have to adjust the Z rotation to fix that. This fixes the horizon line at the start and end frames, but as we start to scrub through the timeline, we can see that the horizon is tilting out of square at the beginning of the animation and tilting back in at the end of the animation. This is not how a real camera on a tripod functions. Let's return to the perspective view and take another look at what's going on. I'm going to turn off the buildings and my females for a moment, and we'll just concentrate on the camera. We can see that the camera is starting tilted up on the x-axis. But when it's rotating on the y-axis, the camera is already tilted up. So rather than moving to follow the horizon line, it's rotating around itself. And this is what is causing the horizon line to skew, which is why we're having to animate the Z rotation to correct this. Let's take a look at how a real tripod works, and then we'll take a look at how to rig up a fake tripod head in Hitfilm. So here we have a camera mounted on a fluid head tripod intended for video use. And we can see that rotating the camera from side to side on the y-axis is independent of tilting the camera up and down on the x-axis. The way the tripod head is jointed, even with the camera tilted up and down, rotating on the y-axis from side to side is going to rotate the camera directly on the y-axis from side to side. Basically, with a video fluid head tripod, the rotation order is Y, then X. And by taking a look at a tripod designed for still photography, we can see that it is still jointed the same way. The X and Y axes are independent of each other, but the rotation order is still effectively Y first and then X. This photographic tripod also has controls to roll the camera from side to side, which is jointed independently of the X and Y rotation. The rotation order of this tripod is Y, X, then Z. To get the YX rotation order we need to accurately simulate a tripod head, we're going to have to create a point rig and attach our camera to it. I'm going to create a new point. I'm going to make it a 3D point. I'm going to parent it to my existing camera, and I'm going to open up its transform controls and set its position to 0, 0. We can no longer see this point because it is at the exact position of our camera, so we're kind of looking through it. I'm going to rename this point Camera X Tilt, because that's what it is. And as we saw a moment ago when I was showing a real tripod, the tilt position of a tripod is actually below the position of the camera. For that tripod and camera combination, the tilt point of the tripod is about 3.5 inches below the camera. At a scale of 1 inch equaling 2 pixels, that is 7 pixels below our camera. So I'll set the position of the X tilt point to -7. I'm going to unparent the X tilt point from the camera, move the X tilt point below the camera, and I'm going to parent the camera to the new X tilt point. I'm going to go ahead and duplicate the X tilt point and rename this camera Y pan. I'm going to go ahead and move camera Y pan down about 13 pixels. Technically, I don't need to do this. I just move the Y point position off the X point so that they don't exist in the same position in space. It makes it easier to grab and adjust them later on. I'm going to parent X tilt to Y pan. The names X tilt and Y pan define what they do. The camera X tilt point is only keyframed for X-axis rotation. The camera Y pan point is only keyframed on Y-axis rotation. I'm going to select the camera X tilt point, move the playhead to about 5 seconds, activate keyframing on the X rotation, and set that value to -60. And there's our flying arrowhead. I'm going to move back to the first frame of the animation, select the camera Y pan point, activate its Y rotation, and then I'm going to kind of find my arrowhead again by adjusting both the X and Y points individually. I'll move to the last frame of the animation, and adjust my X and Y points individually. Actually, I think at the first frame I'll go ahead and lower that a bit more. And now when I scrub back and forth through this animation, we can see that the camera is tracking our arrowhead without having the distortion of the ground plane. The camera is now moving like it's on an actual tripod head. The advantages of having the camera respond accurately like it's on an actual tripod head outweigh the disadvantage of having to adjust 2 points individually. So if we return to the perspective view and turn off our building and our silhouettes, but leave the X tilt and Y pan points selected and scrub the timeline, we can see what's happening. The camera itself is parented to the X tilt point. The X tilt point is parented to the Y pan point. This means that the Y pan point is affecting camera motion before the X tilt. And we can see here as we scrub the timeline that the X tilt point is tilting the camera up and down around the Y point, which is panning from left to right. And this is how an actual tripod moves an actual camera. This type of virtual tripod head, also called a yoke rig, is the basis for other, more complicated camera rigs, as well as being useful when animating objects in general. Point rigs, to change the XYZ Euler rotation order, are vital for getting naturalistic animation in all kinds of situations. But this is where we're going to stop for this week. In the next episode, we'll look at other more complex camera rigs, including sliders, jibs, and cranes. I'd like to thank you for sitting through this tutorial. I'm Mike Miller from Tri-M Visual, and I'll see you next time.